All right, example 5, we're going to find the surface integral of f of x, y, z ds, where f of x, y, z is defined to be z squared, and s, or our surface, is the cone z equals the square root of x squared plus y squared, where z goes between 1 and 2. So it tells us that this is a part of a cone. Specifically, it tells us z is only going between 1 and 2, so it's only the top half. We could tell that because the square root itself was positive anyway. It did not include the negative square root. So it's just the top half of a cone. But it's not the full cone. It's actually only going to go from 1 to 2. So if we kind of sketch this real quick, the full cone, if I were to draw the full thing in there, would look something like this. Whoops. I'm going to erase that so it's okay, but that would be the full cone. We're only talking about, however, between z equals 1 and 2, so it's actually going to cut it off somewhere like right around there. Now I'm going to redraw that whole thing just to make it better because I am not happy with that at all. But our cone is going to start at z equals 1, so it's going to start like right here, and then it's going to go up to z equals 2, so it's going to go up to right there. So it's going to look something like that. So we're just talking about the surface integral on the outside portion of that cone. Notice that this does not say anything about the top or the bottom, so it's just the lateral face of that cone. It is a cone, so I'm probably not going to go with your trivial parameterization. Probably going to go with something in cylindrical here because I think that's going to be easiest. You could certainly go with spherical, but I think cylindrical seems to be like it's going to be the easiest one here. So in cylindrical, x is r cosine theta, y is r sine theta, and we have to figure out how to put z in terms of r and theta, but z is x squared plus y squared, so it tells us that z is square root of x squared plus y squared. But remember, in cylindrical, x squared plus y squared is r squared. So z is the square root of r squared, which is just r. So now z is in terms of r and theta. So let's go ahead and write our r of r and theta. I know that's always weird to see it like that. It's going to be r cosine theta, r sine theta, r. Now we have to take the partials because we're going to need the cross product. So we'll do r sub r. With respect to r, this is going to be cosine theta, sine theta, 1. With respect to theta, the partials are going to be negative r sine theta, r cosine theta, 0. Yeah, that's right. Got to do the cross product. Oops, that should be an r down there. Cross r sub theta. So again, eliminating the r row, the I row and column is going to give us 0 minus r cosine theta, so we get minus r cosine theta. Eliminating the j row and column is going to give us 0 minus a minus, so that's plus r sine theta, but then we have to change the sign, so it still becomes minus r sine theta. And then eliminating the j row and column is going to give us r cosine squared minus r sine squared, or plus r sine squared. And of course we can factor out the r from that and get cosine squared plus sine squared, so that's just going to be a 1. So what we're going to get for the cross is negative r cosine theta, negative r sine theta, r. Okay, we need the magnitude of r cross r theta. Magnitude is each piece squared underneath the square root added together. So the first one is going to be r squared cosine squared theta. The next one is going to be r squared sine squared theta plus r squared. And it looks to me like I can factor an r squared out of everything, and if I take the square root of that, it just becomes an r on the outside, so that gets rid of the r squareds. Then I have a cosine squared plus sine squared plus a 1. So cosine squared plus sine squared itself is 1, plus the 1 left over from this r squared here, so that just gives me a square root of 2. Now we're ready to go ahead and set this thing up in the double integral. All right, so let's see. We've got this in terms of r and of theta. So theta we know goes from 0 to 2 pi. R in this case is going to go from 1 to 2 because remember r is z, and it already told us that z goes from 1 to 2 right there. So since r and z are the same, r or z, either way you want to look at it, goes from 1 to 2. So r goes from 1 to 2. Oops, our function was z squared. Well, z is already in terms of z, so we need to put it in terms of r, so that'll become r squared times the cross product, which is r root 2 dA, which is going to be dr d theta. So this one we can split apart. We're going to get the integral from 0 to 2 pi of d theta times the integral from 1 to 2 of r cubed root 2 dr. Oops, don't want to write d again. Dr. There we go. So the integral from 0 to 2 pi of d theta, we've done that enough times. We know that that is just 2 pi. Let's see, this one is going to give us, I'll pull the root 2 out to the front, and then we're going to get 1/4 r to the 4th from 1 to 2. So all the constants here is going to give me, what is that going to be, pi root 2 over 2, I believe. And then plugging in 2 to r is going to give me 2 to the 4th, which is 16, minus 1 to the 4th, which is 1. So that gives me 15. So it looks like what we get is 15 pi root 2 over 2. That is our surface integral.